My name is Richard X, or otherwise known as Richard Davidson. This is my Week 7 video tutorial on Coursera for an introduction to interactive programming in Python. So let's get to it. What I'll be doing today is basically just going over phase 1 of our mini project Spaceship. Now, don't worry, there will be other videos from me for phase 2 and phase 3. So if you're having problems with those, watch those. I'll post them all together. So, let's look at step 1. Now I think this is one of the easiest things, so we'll skim over it really fast. Modify the draw method for the ship class to draw the ship image without thrust flames instead of a circle. So basically, they've already given you the position of the middle of the canvas, and that's the center of the circle. And of course, you could just easily calculate it using the width and the height, but that doesn't matter now. So, based on the circle's position, you can use a draw image handler for the ship class and draw instead an image, which is the image of the ship. So there's a self.variable for that, and then use the variables that you see inside the ship classes in it. So basically just pick and choose those, and using the docs, fill in the needed information and the parameters inside the draw image function. After that, and you successfully run it, then you should see a spaceship in the middle of the screen. Now before I go from 2 to 11, or show you 2 to 11 and how they work, let me show you a quick demo of my implementation of phase 1 of this spaceship project. Now you can see that I'm open code sculptor, but don't worry, everything is all either folded or commented out. Well, you can still see comments, but they're useless, and it's not gonna give you away anything. Okay, let's move this into place. Basically, what you need for the phase 1 is just a spaceship in the middle, and usually I commented it out. There's a big red circle right here, and like a little blue or a blue dot right here for the missile and the comets, but I took them out because they're a little bit distracting. So let's start off with the spaceship. It's automatically set to do right, so it's like, I think in radians it's called 0. And what you're supposed to be able to do from like step 3 or 4 is to move it angularly, so its orientation you can change freely using the left and right arrow keys. And down here, although you can't see it, it's saying left and right, left and right. Secondly, the spaceship is supposed to be allowed to move forward. So you can turn in midair, and the velocity, remember, is not supposed to be affected by the orientation. So it's not like you go here and suddenly the spaceship starts moving this way. Okay. Now, let's go on to the finer points of phase 1. Now, this is one of the harder things. Allowing your ship to wrap around the canvas. So basically, all you're doing is transferring the position. So that reminds you that you have to use some kind of self.pause in the update. And as in the instructions or tips it said, use modular arithmetic. And I think it's pretty easy, based on our knowledge of Pong, to find out what you need to use modular arithmetic on. So you know you have to have some kind of position, and you have to have some kind of, perhaps teleporter, something like that. Okay, so that's enough of the demo. I think I've showed you everything. Let me take a quick look to see if I have. Okay, so step 2. Implement an initial version of the update method for the ship. This version should update the position of the ship based on its velocity. Okay, so we know how to update the position of the ball in Pong. So basically, it's the same thing. Imagine that the spaceship is actually a ball, and that it's moving around, and it just looks different. So use the same way of the position of the center of the thing, and update it the same way you would do with Pong. I mean, this project is so similar to Pong in so many ways that it's if you actually completed Pong with 100, you should get 100 on this too. Okay, so I already told you step 2. Let's try step 3. Modify the update method for the ship to increment its angle by its angular velocity. Now, in the code, and I can't switch to mine, there are 2 variables, self.angle and self.anglevel. Now, using common sense, if angle is negative, and say the ship would move left, or let's run this really quickly, and the ship moved this way. Now, how would you adapt the angle so that it would change with the angular velocity? think about that, and it'll come to you very quickly. Back to the instructions. Next is make your ship turn in response to the left, right arrow keys. Add key down and key up handlers that check the left and right arrow keys. Add methods to the ship class to increment and decrement the angular velocity, by a fixed amount. Call these methods in the keyboard handlers, so I'm not going to read the rest of it. So basically what it's saying is what I just showed you. Use the left and right arrow keys and change the angle, or the angular velocity I should say, of the... So by now we should be already past using global variables every time we do a key down or key up handler. So in classes we can create methods, and we can create many new methods of this class ship. And I've seen some people in the forums create like 6 different methods, and they only do like one small thing, and that's totally plausible, although it does require an extra bit of work. So what you need to do is define a method, so you can look at the other methods to try to find out what to do. And you need to change a variable inside the class. And we know that object-oriented programming is based on self.variable, insert variable there. So you can update some kind of self.variable using what I just told you in number 3, changing the angular velocity so that the angle will actually turn. And you can play around with that a little bit to approximate the turning speed. And I'm not going to show you. I was going to, but forget it. Number 5. Modify the keyboard handlers to turn the ship thrusters on and off. Add a method to the ship class to turn the thrusters on and off. You can make it take a Boolean argument, which is true or false, to decide if they should be on or off. Well, basically what I did is create 2 functions, and I don't know why I did this, but I think I was just sleepy. I made 2 functions. It's called turn thrusters on, turn thrusters off. And I should have listened to this parentheses saying just use one function. That just shows you my style is all bad. Well, so what you need to do is you should have some kind of thrust flag. And a flag is something that tells you if it's true or false. So something to tell you that it's on or off, and use that method to turn it on or off. Simple enough. So number 6, modify the ship's draw method to draw the thrust image when it is on. The ship image is tiled and contains both images of a ship. So to make this more easy to understand, let me switch over to the Code Sculptor and show you what kind of tiled image it really is. So if you go up to the ship image and you copy and paste this URL inside this link, or string I should say, because it is a string, let's type this. Okay, so it shows 2 little spaceships. One has no thrusters on, and one has thrusters on. So you know, if you divide it by 2, because it is tiled, this will cut it straight in half, and you can go on from there. And I think that's a big enough hint to know how to do it, just based on that. So let's go back to the instructions, and sorry for the orientation of this. Here we go. Okay, next what I want to do is go on to the next step. Modify the ship thrust method to play the thrust down when the thrust is on. Turn it off when the thrust is off. So what I did was actually go into the key handler and do that. So you probably know how to do that already. Sounds are probably the easiest thing to do, so I'll leave that up to you. Number 8, use the given helper function angle to vector to compute the forward vector pointing in the direction the ship is facing based on the ship's angle. So I already showed you angle to vector, and I didn't realize that you have to use it here. So basically this is just telling you what angle velocity should be. So this angle to vector is using sine and cosine, or otherwise trigonometry, to compute the angle in radians. Base of ship's angle. So the formula is angle to vector parentheses ship's angle, and then I'll leave up to you what you need to do to create that vector and what to do with it. So make your ship accelerate in the direction of this forward vector in response to the up arrow key. You will need to update the velocity vector by a small fraction of the forward acceleration vector so that the ship does not accelerate too fast. And I'm not going to even say anything to this except for the fact that you know what to do. Number 10, modify your position update so that the ship's position wraps around the screen. So that's what I meant, or what I showed you when the ship went from the side and came out the other. And when it goes off the edge. So, like I said, you just need to use modular arithmetic, the position, and something that will change the position based on modular arithmetic. Number 11. Up to this point, your ship will never slow down. Add friction as shown in the acceleration and friction video by multiplying each component of the velocity by a number slightly less than 1 during each update. Now, in the forums, I saw a lot of people had problems with this, and I have no idea why. So, the reason I have no idea why is because you know where the update function is for the ship, and that's because you just built it. Secondly, you actually know how to create the speed. So it's like the opposite of the Pong, where each time you bounce the ball against the paddle, it gets faster. This time, it's going to actually decrease the velocity. So each component means the two parts. So that probably means pause 0 and pause 1, or vel 0, vel 1. And multiplying means obviously multiplying. And a number slightly less than 1. And I'll let you find out what number that is. But the number I used was so close to 1 you would never even think about it. But the reason is the update handler actually runs 60 times per second. So that's why you need to have it very, very, very close to 1. And that's the end of the video. I hope you enjoyed it, and I hope you actually learned other things from it that other people can teach. And remember to upvote on Coursera if you like it. Bye-bye!